let's take a look and see what is going to be done in week 2 of Design 330. Here's the item. It's showing up on Monday the 25th. You'll see a list of what to do this week, and it will be due on the 31st at 11:59 p.m. So it's really important. I'm going to show you something right here. It's called Miyamoto Musashi's Book of Five Rings, and he was a swordsman, a samurai out of Japan in the early 1600s, and he was a monster. He beat everybody, and he was big, he was huge, he was strong. I like to say he was the Shaquille O'Neal of um, of samurai. But at some point, he decided rather than just be big and strong and fast and brutal, that he would actually learn swordsmanship. And he did so. And he had a great career of actually being a helpful person, a useful person, a teacher, and a warrior too. And so at the near the end of his life, he wrote a little book, actually 5 little books. And the first book, he laid out what to do to get good at something. And I like rule number 9, which is really a summary of rules 1 through 8, which is do nothing which is of no use. Do nothing that is useful. So I like to say rule number 9, number 9 is very important. And when we come back here, you've got 1, 2, 3, 4, 5, 6, 7 things to do in 2 parts. You don't have time to do things that are useless. So you have to sort of review it ahead of time. So you've got the scope in mind and you know how it all fits together. And you can do a little bit of planning ahead of time. Musashi was big into strategy and planning. Designers are too. So we don't plan on how to whack people with swords. Thank goodness. We plan on how to build things which will serve other people. So let's take a look. We've got 2 parts, the research and the component parts. So those are both going to be due this week. Under part 1, you'll see it's 1.1 through 1.3. There's 3 parts to it. And in part 2, there's 4 parts to it. So now that we sort of know, and the research, here's water sampling, remote operated vehicles, and piston pumps. That's sort of laying out the basis for our project. And then in section 2, part 2, are the component parts. You have a predefined design that you know works. And you'll see that you know it works because I'm going to give you a video of it working in here. It's always good to base your design on some prior knowledge. And then you can either make it better or make it the same or make it easier to build, or you can make the maintenance better, something. You'll do something. So you're going to document an existing design here. Okay, so do some research about water and document an existing design. So let's take a look at what part 1 research is going to look like. Here it is up here. If you click on it, I've got it open. And you'll see, again, it's a submittal template. You're going to fill this out. There's your name, things. It's part 1, which is a research report for the piston pump for an ROV water sampler. So the first thing you're going to need to do is make some sort of a comment that goes, what is an ROV? Right? You should always be making a list of things that you know or don't know. So, maybe what I'll do is sign in on this one and show you how to there we go. And I'm working this on VMware so that you can see that it can be done. we go. So now I'm signed in, and when I come over to here, you can see I can put notes on it and things like that. So the first thing I need to do, of course, is File, Make a Copy. And I'm going to put it in my own set of files. So now I've got something I can work with. Right? And so we're just going to do kind of a preview right now. But when you're previewing, it's nice to let people know or yourself know what this is. And you can go back then and talk about it. So you might need to know what an ROV is. It says here there's going to be 3 parts to this research report. Something about water sampling, something about, ROV, remote operated vehicle. I just figured out what that was. And piston pumps. And you might not know what a piston pump looks like either. So you might put in a comment that says, and you might have kind of an idea, but you might need some more information on that. So you're going to have like 3 pages or something like that. And I give you, look, you're going to have, for environmental water sampling, you're going to have at least 1 page with 4 paragraphs. And notice that these are all numbered. This is part 1, section 1, environmental water sampling. And item 1, 1.1.1, talks about the needs and purpose of environmental water sampling. You're going to have to do some research on that. And since you've had Design 300, you have a clue on how to do that. And you've had Design 320 and some other classes that help you know how to do that. So you're going to just do a web search and write about the need and purpose for environmental water sampling. Typical tests. What are typical tests? I know a lot of those typical tests because I used to run them when I was in college working in a lab, but this is for you to look up. And I will go over it some more, but that's okay. So we're talking about need and purpose, typical tests, test parameters. What is that? What is a test parameter? So you may not know what that term means, and so you're going to need to make a comment. What is a test parameter? And you can look through here then and go, okay. And if you don't know what a test parameter it is, you can bet other people don't know, and you'll have to tell people about it in your little report. And typical test equipment. So that's going to be a page or 2, much like you did in Design 300, where you made a short paragraph out of these. They can be, I am going to allow you to cut and paste from Wikipedia and other online sources, but I'd like you to make sure that you note those sources so that we can see if they're good sources. A .gov is good, things like that, okay? ASTM, things like that, okay? So your environmental water sampling is going to have 4 parts, and I see what they are, and I can be thinking about that. The next one is about remote operated vehicles. So you're going to want to have a couple of those in there. And since this is for water sampling, aerial drones are remote operated vehicles. Radio operated planes are remote operated vehicles, and cars can be remote operated vehicles. And you can talk about that, but you're probably going to want to focus on one that has to do with water. Okay? Water. So you might be talking about underwater remote operated vehicles. And what do they look like and how do they work? How are they controlled? Because how they're controlled is going to tell you a lot about your designs. And then what are some of the limits on them? How do they, what, can they go really deep? Can they go really fast? Can they handle a lot of pressure? What are some of the limits to them? And what kind of attachments can you put on them? If you're going to be taking a pump underwater, maybe with one of these, then you're going to have to know what kind of attachments there are. Okay, so that's kind of a cool thing that is there and available to you to look at. And again, this is going to be at least one page with these on it. And you'll make a new page when you do this. Okay, but this is just an overview. I'm not telling you how to do it. I'm just giving you an overview. And then the last part of this one is, excuse me, I'm about to, piston pumps. So how does a piston pump work? Theory and operation. What drives them? What makes the piston go? How do you size one? How do you know it's big enough or small enough or whatever? Or it's got enough pressure? And mechanical maintenance considerations. All right, so these are all things that you're going to do a little research about, and I will lecture on each of these. But it's good to have those kind of in your brain and know what you do know and what you don't know and do research. Now, everything you write here has to be backed up with evidence. So if you cut and paste from a site, you're going to have a link to that site so that we can see if it's reasonable or not. All right, so that's sort of the overview of the research portion of this. And I suspect that each page of these will take you maybe an hour. So that's maybe 3 hours of work to get this done. So let's look at the next part, which is component parts. Now I'm not going to make, well, yeah, I'll make my copy of this one right now while we're watching and make a copy of the entire presentation. And again, I'm going to put it in mine. So now I've got my own copy of this one. Okay, and you'll put your W number on and things, but these are the component parts. This is for a piston pump for a water sampler, and this piston pump does work. And so let's take a look at what you're going to have to do. You're going to have to put the assembly sketch in here. Some of the parts are things that you buy, purchased parts, and you're going to have the specifications for those. What is a purchased part spec? Well, in architecture, it's a manufacturing spec. In mechanics, we just call it a cut sheet. It's the information about that part, the size, the material, the operating limits, things like that. And then you're going to also draw some details of the manufacturer parts. This one, I will tell you, you don't know what that looks like yet, but you're going to be looking for those pieces of information. You're going to be going, where do I get this? Where do I get this? Where do I get this? So I'm going to just kind of like highlight this whole thing, and I will make a comment that right now I'm going, where do I get the info? You're all wondering that. That's the very first thing you should be doing as you go that. You have to find an assembly sketch. You have to find purchased parts. You have to find the manufactured part details. Okay, and then you'll need to make the manufacturing part model, and you'll have to make the details of it. And then, design calculations. You're going to be asking about design calculations. In particular, you're probably going to be going, let me just do here, new comment. Go, comment, new comment. Oof. Calcs. Help. There, that might be your comment on that. The design calculations for a piston pump are very simple, but of course you're going to be going, I don't know what you're talking about. I need to find that information in the lecture material. And so for the assembly sketch portion, there's just a sketch and it's provided by the project leader. Oh, that's kind of cool. I'm going to give that to you. And you just put it in there. But the purchase parts, there's 1, 2, 3, 4 different types of purchase parts. And so you're going to have to make sure that you've got those specs for each of those. So these might come up. And again, you're going to look at this and you're going to go, wow, this is part 2, section 2, item 1, 2, 3, 4. So you see, when you specify these things, it's going to make it easy to go find them when we talk about them in the future. Okay, manufacturing, there's a raw stock drawing, there's a machining detail, and there's an inspection drawing. You're going to have to make 3 little drawings off of that model. And okay, so now we're on the design calculations. Pump capacity, and that might be a term that you don't even know what that means. What does it mean? And so as you're looking through things, you might look for a keyword like that in the YouTubes that or listen for those and go, okay, I got it. Spring load, something about springs, maybe that isn't too bad. O-ring crush. There's another one. Maybe these make sense to some of you if you've done some mechanical work with pistons before, but this might just be like nonsense to you. And so you'll be looking for that. You'll be looking for clear information on that when you go to the calendar to look through the lecture material. Okay? So there you go. That's your preview. You've got 2 things to do. Let's come back here. You've got part 1 and part 2. Those will both get submitted, and each one has a little section. And now you know what to work on. You know what will be useful. Number 9, number 9, number 9. Nothing that is of no use. So this is where you'll put your effort for the week.